All right, what's up, guys? I hope you guys are having a wonderful weekend. I decided that now would be a great time for us to go over some of the test-like questions that we're going to be doing in class before we have our test on Wednesday and Thursday if you're in Math 2, and before you have your test on Friday if you're in Math 1. So we're going to start with Math 2. I'll put timestamps in the description so that you can see, where your class's content should be. But here is the problem that we did on Friday about dogs and cats. It says here in a survey, 30 people were asked about their pet preferences regarding cats and dogs. 3 of those people who like cats do not like dogs. 22 of the people like dogs, and then 14 of the people who do not like cats like dogs. The first question we had to answer was, how many of these people like neither cats nor dogs? Show or explain your thinking. So right now, the first thing I'm thinking is either I need to make a Venn diagram or I need to make a table. I'm going to make a table first, okay? So let's go ahead and zoom in a little bit here. I'm going to make a table first using the information they gave us. And the first category that I want to have are people who like dogs versus people who don't. Let me use a different thickness. This is too thick. Dogs versus no dogs. And then they like cats versus they don't like cats. Okay. I'm going to leave enough space to have a total on the end for each. This is my total on this side, and then this row will represent my total right there. Okay. So we know that from the first sentence, as 30 people were asked about their pet preferences. I know that that's 30 total. I know for a fact that that's everybody surveyed, right? So that goes in the bottom right. That's the total. Okay. Next, 3 of the people who like cats do not like dogs. So they like cats, and they don't like dogs. So I go to my table, I see, oh, cats is right here. They don't like dogs. Oh, no dogs right here. This is where my 3 is going to go. Okay. Next, 22 people like dogs. Okay, so if they like dogs, it does not say anything about whether or not they like cats. So I'm going to assume that this is actually the total people who like dogs, regardless of whether or not they like cats. So that would be dogs. I don't know. Yep. I'm going to put that down here. Okay. Next, 14 of the people who do not like cats like dogs. So no cats, yes dogs. Okay, so I'm going to go no cats, yes dogs. These guys are going to go right here. Okay. Next, I can start filling in some things because I know that this total is going to be the sum of all of this column. So I know that something plus 14 has to be 22. Well, that something has to be 8. Okay. 8 plus 14 equals 22. Now this total right here, same thing. 8 plus 3 has to equal something. Well, 8 plus 3 is 11. And I'm going to continue this process to fill out the rest of the table. 11 plus something has to be 30. Well, 11 plus 19 is 30, so I know a 19 is going to go here. I know that 14 plus something is going to be 19. Well, that has to be 5. And then lastly, oh, for some reason it's not updating. There we go. 3 plus 5 is going to be 8. And then I can verify that that is true because 22 plus 8 is 30. Okay, now that we have this whole table set up, we can go to these questions. How many of the people like neither cats nor dogs? That means they don't like either of them. So I'm going to go here. I'm going to look. Okay, these people like dogs and cats. That's not them. Oh, these people don't like dogs. Oh, but they like cats. No, they got to like neither. 5 is going to be my answer here. Five people like neither cats nor dogs. Okay? And then if I had to write a little sentence on my test, I might say something like, according to the table we completed, 5 people like, sorry, we'll put don't like either. Cats. Oh. cats or dogs. Okay. Next we go to part B, which is what is the probability that a randomly selected person from the survey likes cats or likes dogs? So you could be that guy or that girl that memorizes all the formulas in math class, but I was not that guy. Okay? The formula for OR is probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay? And for me, for my money, I would rather not do 1, 2, 3 different calculations and then risk also, you know, making a mistake in the calculator if I'm just, you know, making a misinput. I would rather think about this logically and go, okay, if someone likes cats or dogs, that could include people who like cats and dogs. They like both. It could include the people who like cats but don't like dogs. It could also include people who like dogs but don't like cats. The only people that are now excluded is actually the answer from the previous question, which is the people who like neither. Okay? So the only people not included, they're the people that don't like cats or dogs, right? I add up these three right here because these people like either or. And in this case, these guys like both, right? 14 plus 8 plus 3. Those are all the people who like either or. 14 plus 8 plus 3. Okay? I'm going to highlight that. Let's use a different color so you guys see where that comes from. This is in green. This is our OR. Right? Those people out of how many total? Well, first sentence told us there's 30 people surveyed, and right here in the bottom right of our table, there were 30 people surveyed. Okay, so now I just do my math. 14 plus 8 would be 22. 22 plus 3 would be 25. So I have 25 out of 30. That is the probability of A or B. In this case, A might be people who like cats, and B might be people who like dogs. All right, so now that we are done with Math 2's question, we're going to start with Math 1's question. This is just like the first few problems of you guys' test that we're going to have on Friday. Okay? We're going to see questions that look a lot like this. Which of the following are equivalent to each other? Select all that apply. And when you guys see this question, what I'd like you to do is isolate one variable. You'll be able to tell which ones are equivalent if you just isolate one. And when I look at these options, immediately B and C already have Y isolated. They already have Y on one side of the equation. So if I want to save myself some time, I'm going to do the same thing that they already did for me. They isolated Y on both of these. I just need to isolate Y on A and isolate Y on D, and then I'll be able to see which ones of these are equivalent. Okay? I'm going to start with A. I'm going to rewrite that equation. We have 3x minus 2y equals 12. And we know that when we're trying to isolate the variable, we need to do the opposite. That means the inverse operation. Okay? So if I want to get rid of the 3x that's on his side, what I want to do is do the opposite of 3x, which is negative 3x. And what I do to one side of the equation, I must do to the other. What ends up happening here is these guys cancel out, right? Because 3x minus 3x is 0, right? Okay, let me make that clearer, that we cross both of those out, okay? And then we get 12 minus 3x. Now, a lot of students make this mistake. They'll be like, oh, that's 9x. Well, these are not like terms. If you would be right if this was 12x and 3x, but no, this is 12 and 3x. These are not like terms. We can't combine them yet, so I leave them alone. They're just 12 minus 3x. Okay, I copy down everything else. And now, actually, there's only one step left, right? There's only one more number on y's side, and that number is negative 2. And I have to ask myself, what is this negative 2 doing to the y? Well, I don't see any operation happening between these two, so I assume that it is multiplication. And the opposite of that is division. So I'm going to divide by -2. And what I do to one side, I must do to the other. Okay. These guys obviously cancel out because -2 divided by -2 is just 1. And we're just left with 1 times y. And anything times itself stays the same. So I'm just left with y equals all of this divided by -2. Okay. If I want to save myself some time too, I could do this step all in one right here, like 12 divided by -2. Well, 12 divided by 2 would be 6. And then positive divided by negative. Oh, that's going to give me a negative. And then over here, I'd have -3 divided by -2. I could just leave that as a fraction, because I see also when I look back over here, all these are left in fraction form. So it might be easier for me to tell if these are fractions. So I'm going to go -3 over 2. -3 over -2. Oh, that's the same thing as a negative divided by negative. Oh, that gives me a positive. So this is going to change to plus 3 over 2 times x. Right? And if I want to reorder this to look more like these, I know that the fraction goes first in these. So why don't I just move this guy in front? I'll go y equals 3/2 x minus 6. Oh, well, he matches B, doesn't he? Okay, cool, I'm done. A and B match, right? But here's the thing. When you guys see a question on the test that says select all that apply, or select all correct answers, anything like that, anytime you see select all, you need to test each and every single individual answer. Okay, so right now we only solved A. And for the sake of my question, this is the correct answer. It's only A and B. But when you get to the test, test every single one. Isolate the variable on every single one to see which ones match. Okay? I hope you guys had an awesome weekend. I will see you guys on Monday. I'm super excited to get to class. You guys have a great rest of your Sunday. Bye-bye.